So keeping this pattern in mind, and this here, this shortcut is on your MCAS reference sheet. So you will always have access to this. So to solve problem 7, you notice how 9 is the length of one of my legs. Well, that's x. So that means this side will also have a length of 9, and the hypotenuse will have a length of 9 times the square root of 2. Now, and that's your final answer. You're not to convert it to a decimal or anything like that. That's all they're looking for here, okay? For number 8, you'll notice even though the triangle is turned, this is the hypotenuse across from the right angle. So that means this is equal to 3, and this is equal to 3 times the square root of 2. Okay? The whole idea behind this is that this is kind of like a shortcut. This means you do not have to go through solving Pythagoras' theorem. Okay? Now, for number 5, we're given the length of the hypotenuse. Now remember that the number in front of the square root of 2 is the length of the leg. So each of these legs are equal to 5. And for number 6 is also very similar. This is my hypotenuse. So the number in front of the square root of 2 is the length of my leg. So each of these have a length of 6. Okay. Now, when we talk about special right triangles, there are 2 specific ones that we have in mind. The first one here is what we call a 45-45-90 triangle, and that refers to the 3 measurements of the angles. So obviously we have the 90-degree angle and then the 2 smaller acute angles of both 45 degrees. Now, the only time we get or can get a special right triangle with these specific angles is if we divide a square in half diagonally, because we know that squares have right angles, and the diagonal divides those corner angles into 2 45-degree angles. So that's how we get a 45-45-90 triangle. Now, because this is part of a square, all the side lengths are congruent. Okay, so that means the 2 legs of my right triangle will have the same length. And on your MCAS reference sheet, it is referenced by using the variable x. Okay. To find the length of the hypotenuse, which I'll just call h for now, okay? To find the hypotenuse of any right triangle. So to find the hypotenuse, we can use a squared plus b squared equals c squared. And we can use Pythagoras' theorem to find any missing side length of a right triangle. So let's say I give my square a side length. So I'll say a length of 3. Okay, well that means my other side is also 3, obviously. So I have 3 squared plus 3 squared equals my c squared or my hypotenuse. Okay. So 3 squared is 3 times 3, which is 9. Then add that together, and I get 18. And the last step to solve is always to take the square root. Now we can take the square root of 18 and use it on a calculator to get a number, a decimal number. But if I reduce or factor the square root of 18 into simplest radical form, that means factoring out as many perfect squares as possible. Now 9 times 2 is 18. Well, the square root of 9 is 3, leaving me with 3 square root 2. So you notice that the length of the hypotenuse is the length of the leg times the square root of 2. Now this will work for any length of the square. Let's try 7, for instance. Okay, this is going to give me 49 plus 49. Okay. So when I add that together, I get 98. So C is the square root of 98. But if you notice, I can factor 98 into 49 times 2, because that's what 49 times 2 is. It's 49 plus 49. So that's the square root of 49 times the square root of 2. Square root of 49 is 7. Okay, and that was the length of the leg I gave. So regardless of whatever measurement the leg of the triangle is, the legs will always be the same, measurement because it comes from a square, and the hypotenuse will always be the length of the leg times the square root of 2. So this is kind of like a shortcut. Let me flip this. Oops, sorry. Let me look at this. Okay. Okay, so this is the one I was looking at. Okay. So here, so this is my hypotenuse. This is x square root 2. This is the length of my leg. This is x. Okay, so to solve, so this side here will be 4 square root 2. The same length as this leg. But don't confuse this measurement with the hypotenuse. Okay? Because the 4 square root 2, that's the length of the leg. That's x. To get the hypotenuse, I have to multiply that leg times the square root of 2. Okay? So just don't assume that because you see 4 square root 2, that's the length of the hypotenuse. It's not in this case, because the hypotenuse is always directly across from the right angle. So what that means is you're just taking 4 square root 2, which is the leg, and multiplying it by the square root of 2. Now, to do that, we can multiply the 2 square roots together, giving me the square root of 4. Now, the square root of 4, I know, is equal to 2. So my final answer is just 4 times 2, which happens to be 8. So in this case, my hypotenuse is a whole number. Okay. Now, if I look at Okay, if I look at number 9, my hypotenuse is a whole number. Now, based on the problem we just did, to get the length of the side, or to get the length of the hypotenuse, meant the side length was half of the length of the hypotenuse times the square root of 2. So that would mean that to get 10 as a whole number, each of these sides would have to equal to 5 square root 2. Now let me show you the math behind how we got that. Okay, so remember our reference. The legs are the same, and the hypotenuse is equal to the length of the leg times the square root of 2. So that is what 10 equals. My hypotenuse has a value of 10. So to solve for x, I'm going to divide both sides by the square root of 2. So that is the length, or the value of x. But it is not in proper form. You can never leave a square root in the denominator. So what we have to do is actually multiply both top and bottom by the square root of 2. It's what we call rationalizing the denominator. So that way we can get that whole number in the denominator. So square root of 2 times the square root of 2 is the square root of 4, which happens to equal 2. And 10 times the square root of 2 is just 10 square root of 2. Okay, but notice I can take half of 10, happens to be 5. So that is how we get the side length, or the math behind getting the side length. But if you can remember, if your whole number is if your hypotenuse is a whole number, if you can remember that the leg is just half of that times the square root of 2, you'll be okay. Because again, it's taking that length and multiplying it times the square root of 2 is what gets me that value of 10.